Welcome back. So this is problem 28 on page 306, and we're going to go through all four operations just like we did for the last one with two different functions. Now these two functions, the first one f of x, before I get started finding f of x plus g of x, I noticed that the denominator of f of x can be factored. So you want to do any factoring before you start picking an LCD. So I'm going to rewrite this one as 1 over, and this factors into x plus 3, x minus 3. So now when I pick my LCD, because I'm adding them and I do need a lowest common denominator, I'm picking the factor that, for each one, I'm going to pick the factor that I need for my lowest common denominator. So for example, for f of x, if that denominator has an x plus 3 in it, then my lowest common denominator has to have an x plus 3. And then it also has an x minus 3 for that first one. So my LCD has to have an x minus 3. The way I describe this is that you can't have lost any factors. Okay, my LCD has to be at least enough to kind of cover each denominator. So if that one has an x plus 3, I need it for my LCD. And if that one, the first one, f of x, has an x minus 3, then I need that in my denominator. So what I have listed so far is enough to cover f of x. So now I look to g of x and see, do I need to add any more factors, or is what I have enough? So g of x has an x plus 3 in the denominator. It just has one of them, and I have one of them already listed, so I have enough. I don't need to take that third factor. The only reason for me to take an x plus 3 and another x plus 3 is if one individual function had two of them, then my lowest common denominator would need two of them. But each one of these only has a single x plus 3, so does my lowest common denominator. So now I'm going to rewrite both fractions with this new denominator. Okay, so I'm going to rewrite it as x plus 3, x minus 3 in both of them. And I'm going to go back to my original one, right? And I'm going to see what did I have to do to the old one to get to the new denominator. So let's see, from my old one to my new one, the first one I didn't have to do anything, right? My denominator stayed the same, so my numerator is going to stay the same. My second one, my g of x, this is a new factor right here that was not there in the original, so I had to multiply both the denominator and the numerator by an x minus 3. So here I'm going to get, I can either distribute this now or I can distribute it after. I'll put it like this for right now. That's going to be my new numerator. Okay, and now I'm ready to add or subtract my numerators. In this case, I'm adding. I'm leaving my LCD the same. And then the top, it will be a 1 plus a 2x minus 6 when I distribute that. I'm distributing just a positive 2. If it had been subtracting these functions, which will be next, then I would have to distribute a negative 2. And so let me rewrite this one more time and combine. So I really have a 2x minus a 5 over my lowest common denominator. And that is the best I can do. That's my simplest form when I add those two together. So when we go to the next one and we subtract them, I don't really have to redo all the work. We know our LCD is what we just picked. So let me just rewrite these fractions again. So we had x plus 3, x minus 3. And the top hadn't changed. And then we had an x plus 3, x minus 3. And this one, we had a 2 times x minus 3. That was me rewriting with the lowest common denominator. So the only difference in this one is I have this minus in between instead of the plus. So now, I do have to be very careful here, because now I have to distribute a minus 2. So my numerator is going to look like this. 1 minus 2x plus 6. And sometimes I get lazy for a second, and rather than rewriting it, I know I have one more step of simplifying. For a second, I'll just do that. I'll say over the LCD. I know I have to, again, my final answer, I'll put it back, but And now I'll combine, so now I have a negative 2x plus 7. Notice I have a different numerator, and I should, when I added, subtracted, I should have two different answers for these ones. So that's lowest form for that. And then lastly, let's look at what happens when we multiply and we divide them. Okay, so if we multiply f of x times g of x, I'm going to use the factored versions. It will always, you don't want to go back to the original, go back to your factored version. So that's my f of x times my g of x is 2 over x plus 3. So on here, for when I multiply these two, I'm looking to see if I can cross-reduce anything, but there's no factors in common in the numerator and denominator. So I just have to multiply across and get, all right, I'll get a 2 over, there's a couple ways I could write this. You could write this and just write all three out. Or you could also do this. You could write it as 2 over, and then if you since you have two identical factors of x plus 3, you could write that as a quantity squared. Either one would be okay. And there we go. That is simplified version of f of x times g of x. A little bit more will happen when we do f of x divided by g of x because of the placement now of the factors. We will be able to cancel something. So let's see. To divide by it, so first let me rewrite it the way it is with the fraction bar, and then we'll decide what we're going to do. So it's 1 over x plus 3, x minus 3, all over, remember I'm using that bigger fraction bar. That's the original, right, when I write it just with the fraction bar. But I know now to divide by that fraction, to divide by 2 over x plus 3 is the same as to multiply by its reciprocal. Okay, so now we actually see there's more I can do here, right? Because now I have an x plus 3 in the top and an x plus 3 in the bottom. So those are canceling to 1. I'm cross-reducing there. So now I go across and gather what's left, and I have only a 1 up top. And on the bottom, I have a 2 times x minus 3. So you could leave it like that. It would not, I'm not really simplifying in this next step. By me distributing, since nothing's combining, it's not technically more simplified. So either one would be okay. If for some reason, you know, my Open Math wanted the second one and you put the first one here, I would go back and give you full credit for that because they're both equivalent expressions and one is really not any more simplified than the other. When we factor something, we're not really simplifying it. We're just writing it in a different way that happens to be useful for certain things, but it's not really more simplified. So either one of these would be okay. Okay, so hopefully those were helpful with those U tries, and have a great week and let me know if you have any questions.